We're going to learn a few more properties today about quadratic functions. So that's why it's property of quadratic functions continued. We are going to identify the minimum and the maximum of a quadratic function, which have any of you done that before in Algebra 1? Okay, so everything is new. Great. I like that. And then we're going to state the domain and range, which we did talk about that a little bit in Chapter 1. And then we are also going to do some real-world applications. Actually, a lot of story problems will involve finding the minimum or the maximum, so I'm going to show you some things today with that. Okay, so the first thing we're going to do is we are going to draw a couple of examples with our properties. So we are just going to draw our own parabolas. I'm going to try to zoom this in because I know it's kind of hard to see. All right. Okay, so the properties. The first graph we're going to look at is when it opens upward. Oh no, that's a bad color, isn't it? Okay, so it opens upward. And yesterday we learned about the condition for that. So it's going to open upward when the A value is positive. Alright, so let's draw a parabola. Really, you can put it anywhere. We're just going to label a few special things on the parabola. So one thing that we talked about yesterday is the vertex. The vertex is either going to be the highest point or the lowest point on your parabola. For this one, it is the lowest point. So here's my vertex. So if it opens upward, the vertex is the lowest point. It is still denoted as HK. And because it is the lowest point, we call this a minimum value. Okay, so it opens upward if the A value is positive. The vertex is the lowest point, and it is still being denoted by HK. Remember that H and K is the same thing as X and Y. It's just H and K represent your vertex. Okay, it's still the X coordinate and the Y coordinate. So sometimes a problem is going to ask you to find the minimum or maximum value. If they ask you that, what they are specifically asking you to find is the minimum or the maximum. Let's see if this has some juice left. Okay, so the min or the max will be the Y coordinate of the vertex. So just think about how we find that, and that is going to come up in a little bit. We are going to put something down here, but before we do that, I want to draw the second one. So it opens upward if the A value is positive. If it's negative, the graph is going to open downward. And then we're going to draw an example of that. So this is when the A value is negative. Remember, the A value is always in front of your x squared term. We're going to draw a parabola. And this is where my vertex is here. It's not on the axis. It doesn't always have to be. Sometimes your vertex is the y-intercept, but that doesn't happen all the time. Okay, so here your vertex is your highest point. Okay, and again, it's still your HK. All right, so it opens downward because your vertex is the highest point. That means you have what is called a maximum value. If you're watching at home, it looks like an earthquake. I'm just moving everything. All right, so now we're going to talk about the domain and the range. So remember in chapter 1, we filled out that chart of all the parent functions, and we filled out the domains. Do you guys remember what the domain was for most of those functions? No? All real numbers. Does that ring a bell? All real numbers, the domain? Okay, really, what is the domain telling us? What does the domain correspond to? Yeah, of course, I heard somebody say x, right? It's all of the possible x values. Okay, so when you are doing the domain, I'm actually going to teach you a new way to do this. But for right now, I'm going to write it the old way first. So we talked about how if you have the domain, it's all real numbers like this, where you're using the capital R with the line through it as your symbol for the real number set. Today we're going to learn a new notation. Okay, so the domain is the set of all possible x values. What is great about quadratic functions is you can plug in any number and you can get an output. Do you guys remember the one function that we talked about where you couldn't? Yeah. Yeah, because in the square root, what can't you plug in? The negatives, because that would be something that's undefined. Okay, we also talked about like fractions, because what can't you have in a fraction? You can't have the denominator be 0. Okay, so that's where you have some limitations. But for quadratics, it's going to be all real numbers, which is nice. Now the range is the set of possible y values. So if you look at this here, you can see that this is going to be the lowest y value, and all the points are above that. Do you guys remember how we can write that with symbols? So if this is the lowest y value and all of them are above it, what symbols are we going to be using? Yeah, good. Okay, we're going to be using the greater than. So y is greater than or equal to this lowest y value. What's the lowest y value if you know it's the vertex? Yeah, k. So y is greater than or equal to k. Alright, so what that means is all values greater than or equal to the y value of the vertex. And so what's great about that is this is like a formula now. Once you know what your vertex is, you can plug in that value for k. Because it's always going to happen like this for a minimum value. What we're going to learn today is something called set builder notation. It is fancy. It has to do with sets. And that's how we're going to be writing our domain and range, okay? So we're going to write set builder notation. Set builder notation. And this is how we're going to be writing our domain and range. This is how you'll be asked to write it on your quiz. We're going to practice now. So maybe you guys remember back in middle school, you guys had to do sets of numbers. You don't have to write this part down. So like sometimes you'd have to find all the odd numbers, right, in a set. So 1, 3, 5, 7. And you guys remember you had those fancy brackets? Those ring a bell? Some of you have trouble with the fancy brackets. I like to do, sometimes sound effects help me. I go whoosh, whoosh, or bump, bump. Okay? So that's what we are going to do with this. So set builder notation, fancy bracket. Okay, 1, 2. And then we have X, and then we have a straight line there. Straight line can be translated to such that. So what this means is all values of X such that X is an element in the real number set. So look at all of those beautiful symbols. So this is like a soft E, it means element. Then we have the R for the real number set. Okay, so all values of X such that X is an element in the set of real numbers. So anytime you're doing set builder notation, you're always going to start with the fancy bracket. Now for this one, it's going to be all values of Y such that, and then this is going to stay the same. So Y is greater than or equal to K. Alright, and then we're going to do the same thing for the maximum. So first we'll go over this, how you're familiar, right? So the domain, always all real numbers, but the range is going to change if it is a maximum, because all of the points are not above K, now they're going to switch. All the points are where? Below it. So our sign is just going to flip. Y is less than or equal to K. Okay? Okay, so it's less than, equal to the highest Y coordinate, which is your value of K. So less than, equal to the highest Y coordinate, which is your K. Alright, so let's do that in set builder notation. You can try that for me, both of them. Okay, so this is X such that X is an element in the set of real numbers. Alright, and then again I'm just going to write, this means all real numbers X. And this means such that. Okay, so all real numbers X such that X is an element in the set of real numbers. Alright, and then let's try it for Y. So this is all real numbers Y such that Y is less than or equal to K, fancy bracket. Okay, so when you are writing your domain and your range, you are going to write them in set builder notation. Alright, questions for me on those properties? You guys ready to find some properties of some functions? Okay, so for example 1, it says to find the minimum or the maximum value of the function. And then we're going to state the domain and range of the function. So find the min or the max, okay, and then we're going to state the domain and range. So like I said, on your quiz, you're going to have to do it in set builder notation. So I want you to use set builder notation for this. And then for a, your function is f of x equals negative 3x squared plus 2x minus 4. Alright, so the first thing is asking you if it's a max or a min, and how do you know? Is it a max or a min, how do you know? So, we are going to work on our explanations, because again, on your quiz you are going to have to explain some of these things. So, if it is a max or a min, Evan, can you tell me how which one it is for A? Okay, tell me how you know.
It's going to be a max because the parabola goes down and A is less than 0.
Good. Okay, so it's going to be a max because your A value is less than 0, which means we know that the graph opens down. That's excellent. Okay, so is it a max or a min? How do you know? F of x, which is our function, has a max because, and it's all about our A value, because A equals negative 3. Okay, so if A equals negative 3, this means the graph opens downward. And sometimes too, I'll for my own benefit, I'll just draw a rough sketch and I'll say, yep, it's opening down, so I have a maximum. That helps you with my domain and my range. Okay, and that is our first step. Is it a max or a min? How do you know? Okay, I am telling you that on your quiz you will have to explain it, so make sure that you can identify the A value and what that tells us about the graph. Okay, the second thing we are going to do is find the max and the min, and this should say by finding the x and y coordinates. Okay, so the max or the min is going to be the y coordinate of the vertex. But in order to find the y coordinate, I have to find the x. Okay, so let's think back about how I find the x value of the vertex. Okay, do we remember how to find the x value of the vertex? Yeah, all right?
Negative b over 2a.
Good, okay, so we're going to use the opposite of b over 2a. Okay, so go ahead and calculate that. It is going to be a fraction, and we are going to do mental math. Okay, so Brandon, what's my b value for this?
Negative.
Okay, yep, that's my opposite of b. Yep, so b is 2, so opposite of b will be negative 2. Good. And then this is 2 times a. Barra, what's my a value?
Negative 3.
Perfect. So then I have negative 2 over negative 6. What does that reduce to? 1/3. Okay, good. And then it'll be positive because you have a negative over a negative. Okay, so x equals 1/3. Alright, so if x equals 1/3, I can find the y by plugging it into my original function, which we are going to do today using mental math. Alright, so work through this with me. Okay, so f of 1/3 equals negative 3 times 1/3 squared plus 2 times 1/3 minus 4. Alright, so we're going to dust off our brain. We're going to remember our order of operations. So the first thing I want you to do is simplify with any exponents. We don't have any terms inside parentheses. Okay, so I want you guys to do that. Okay? Remember how to apply an exponent to a fraction? Apply the exponent to the top and apply it to the bottom. Don't use your calculator for this. I'll let you use it for the next one. Okay, so when you square something, you square the top and you square the bottom. So 1 squared is what? 1. 3 squared is 9, so this should be 1 over 9. Plus, and then we talked about this earlier this year, right? You have a whole number and a fraction, you multiply the whole number by what part of the fraction? The top. Okay, so 2 times 1/3 is 2/3. Okay, and then with this one, if I were to multiply, I'd have negative 3 over 9. What is that going to reduce to? Yeah, negative 1/3. So I'm just going to do negative 1/3 plus 2/3, which this makes me happy. Why? They have a common denominator, right? So I don't have to do anything. Just negative 1/3 plus 2/3 is 1/3. So this is 1/3 minus 4. Now, can some of you think of this in terms of a whole and do that as a mixed number? Yeah, for some of you, I think that might be easier. Is you think, okay, if I had 4 and I subtracted 1/3 of it, I'd have 3 2/3. You could think of it like that, and then just put the negative on. Or you could get a common denominator. If you want a common denominator, you'd want the bottom to be 3. What would the top become so that it's equivalent to 4? 12. Okay, now 1 minus 12 is negative 11, so negative 11 over 3. I would accept either of those answers. Do you guys remember how to turn a mixed number into an improper fraction? I know it's been a while. Yeah, multiply denominator by the whole number. 3 times 3 is 9, 9 plus 2 is 11. Keep the negative on there. Okay, so like I said, I would accept either one of those as your minimum or your maximum. But if this is a nice fraction, I want this to be a nice fraction as well. Okay, if they give it to you as a decimal, then I'm fine as a decimal. But we definitely want to get back into some of those mental math processes. So our maximum is negative 11 over 3. So remember, the maximum is always the y-coordinate of the vertex. We wrote it right here. Not just for funsies, but for when you're reviewing for a test. Okay, if you're going back and you look, you have these little notes that say, oh yeah, it has to be the y-coordinate. Alright, so that's your maximum. Now we're going to state the domain and range. That's going to be our third step. And then this is asking you, what does the domain represent? So remember that the domain is the set of possible x values. And there's many possible x values. In fact, the parabolas extend in both directions, left and right, to infinity, which is why it's all real numbers. For the range, that's going to be dependent on whether you have a min or a max, because the range is the set of possible y values. And remember, we are doing this in set builder notation. Okay, so your domain is all values of x, such that x is an element in the set of real numbers. And then I want you to give your range a try. did say if you have trouble with the domain and range, try sketching just a rough graph of your function. And by rough, I just mean, is it opening up or down? You know that this is your maximum value, the 1/3, negative 11/3, and it's all about the y-coordinate, okay? So it's all of the points that are at the vertex or below. So when you are writing that, it's going to be y such that y is less than or equal to negative 11/3. Okay, and that's going to be your domain and range. Okay, and then make sure you put your fancy brackets. And then part B is going to be the same, so I'm going to give you the function. I'm going to have you do that on your own, okay?